And today we're going to be learning about tree diagrams in order to figure out some more complicated probabilities, okay? So we want to be able to use tree diagrams to determine what the sample space is so that we can actually calculate some fairly complicated probabilities. So we are going to take a lot of time today to do this. All right. So first, we use tree diagrams when there's more than one action or choice. We've been dealing with I'm flipping a coin a bunch of times. But now we're moving on to more complicated things where we're going to do maybe flip a coin and then spin a spinner, and we want to know what the outcome is. Or roll a dice and spin a spinner and then do another spinner. Like, it's just a series of things that will happen. And so when we have more than one action or choice, it results in several outcomes. And a tree diagram is a useful tool for organizing and showing all the different outcomes. So number one here, this spinner is going to be spun 2 times. So what happens here is I'm going to spin this 1 time. What are my possible outcomes that I could get from my very first spin? I could get an A, I could get a B, and I could get a C. So that is my first spin. Then I'm going to spin another time. Maybe that first spin I landed on an A. I'm going to spin again. What might happen the second time around? I could get an A, I could get a B, I could get a C. Maybe the first time I landed on a B. What could happen the second time I spin? I could get an A, I could get a B, I could get a C. Maybe that first spin I landed on a C. What could happen the second time? A, B, or C. Okay? This is what I would call the simplest tree diagram that we could do. And so what could happen here for our sample space are all the combinations that we can run the branches through. So my sample space here was, first I could have started and gotten an A, and then the second spin I'd get an A. Or it was A and then B, or A and then C. So that is the first little branch here of those results. I could have gotten a B first, followed by an A, or a B first, followed by B, or B, and then C. And then last, it was I started with a C, and I could have gotten an A, CB, or CC. And those are all the different ways that we could spin that spinner 2 times. Does that make sense to you? Okay. So what we can see is that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes. 9 possibilities here. And now that we have that, we can use that information to figure out some pretty complicated probabilities. So over here, we want to know the probability of getting a B 2 times. How many places here in our sample space did we get a B 2 times? Just one. They're right there. We had the B winner, BB, all right? There was only 1 time. Out of how many different possibilities? 9. So that's our probability, 1 out of 9. What about the probability of getting at least 1A? What does it mean to be at least 1A? At least 1A. At least 1? Would 2 work? Yeah, okay. So at least 1A means an A or maybe 2 A's. All right, so how many places do we have an A or two A's? All right, we got one here. There's at least one A, at least one A, at least one A, and there. 1, 2, 3, 4, 5 places where we got at least one A. So 5 winners out of 9 possible outcomes. All right, what about the probability of no C? What does that mean, no C? No C at all. A's or B's are fine. All right, so let's see, A's or B's are fine. So this one works, A's and B's are fine. Not that one. A's and B's, no C. A and B, no C. Oh, there it is. Okay, so how many? None. 4. 4 little highlighted no C's out of 9. Do you have questions for me? Good. All right, let's try another. The popcorn stand offers buttered or unbuttered popcorn in 3 different sizes, small, medium, and large. All right, so you go up to the popcorn guy and you're like, I'll take some. What do you say, buttered or unbuttered? Buttered? Yeah, buddy. All right, buttered or unbuttered? All right, now we chose buttered because who wouldn't? And from there, what size do we get? What size do we choose? Small? Anybody choose small? No, because it's like only $1 more for a large, right? Okay. But we could have a choice. We do have choices, small, medium, or large. And we could, again, choose unbuttered. I don't know who would choose unbuttered, but small, medium, or large there, okay? And so we want to list what our possible outcomes are. So we could choose a buttered small popcorn. What else could we choose? Buttered medium and buttered large. Or we could choose unbuttered. Ugh, I know, right? Unbuttered small, unbuttered medium, and unbuttered large. Because, like, why not? It's only $1 more. I mean, you already paid $7 for the small. Why wouldn't you pay $8 for the large, right? Okay. All right, how many different outcomes are possible here? 6 different outcomes possible here. All right. So, what's the probability that our popcorn is going to be buttered? 3 out of 6, buttered, buttered, buttered. We've got 3 buttered options out of 6, which reduces to 1/2. Okay. Yeah. What about the probability of choosing a large one? How'd you get 1/3? 2 6. Yeah, here's a large, there's a large. We got 2 larges out of 6 options, which does reduce to 1/3. What about the last one here? The probability of a small with not butter. 1 6. Right there is the small with no butter. So that is just 1 out of 6 for that one. Yeah. All right. Small with no butter. Unbuttered small. Okay. How you doing? You think you get this? Yeah? Okay. Let's do one more, and then I'll set you on your own for the other side of this paper. Yeah. Okay. Essentially, that's your work. I've got half a worksheet for you to do, too. But this is what you're doing today. All right? I want you to be good at tree diagrams. So that was the whole point today. All right. You have a choice of vanilla or chocolate ice cream topped with sprinkles, peanuts, granola, or M&Ms. Who would choose granola? Okay, sorry. Oh, Jace raised here. I would too, Jace. I eat granola every morning on top of my yogurt and blueberries. All right. So we've got vanilla or chocolate as our first options. It's pretty good chocolate, vanilla or chocolate. Good solid flavors there. Okay. All right. And then if I chose vanilla, what are my other options there? Sprinkles, peanuts. Oh, I drew too many. All right. Granola, because I can't count. And M&Ms. All right. Bag 'em, spig 'em. All right. Sprinkles, peanuts, granola, and M&Ms. And if I choose chocolate, I get the same other choices as well. So sprinkles, peanuts, granola, and M&Ms. All right. So what are my possible outcomes here? Vanilla sprinkles, vanilla and peanuts, vanilla and granola, and vanilla and M&Ms. What are my other outcomes? Chocolate and sprinkles, chocolate peanuts, chocolate and peanuts sounds really good right now. Chocolate and M&Ms. I'm not a huge fan of M&Ms since I found out how they make this shell so shiny. Boiled beetles. From the shells of beetles. No. My vegan friend. Yeah. Yeah. Anyway, yeah. Well, you think about their shells, right, of beetles, like they're like all like super shiny and like iridescent, but it's whatever makes that shiny iridescence. So it comes from, yeah. All right. I digress. Let's go back to math. Okay. How many outcomes here? 8 outcomes. 8 outcomes, 8 different outcomes here. All right, what's the probability of getting a chocolate ice cream? 4 out of 8, 4 out of 8, which is 1/2. Very good. What's the probability of getting some M&Ms? Yeah, 2 out of 8. There's 2 options with M&Ms, so 2 out of 8, which reduces to 1/4. Very good. And then what's the probability of vanilla with sprinkles? Yeah, just there was the vanilla with sprinkles, 1 out of 8. Very good. How are you feeling with this? Really good? Okay, your job right now is to turn the page and complete 4, 5, and 6. And I have 3 more for you to do on the worksheet. Yeah. I'm sorry?
I got hurt.
Oh, Band-Aid. Yeah, I can help you with that.